Hi guys, welcome back to another video in this tutorial series where we're talking about EMV tags, right? And in this video we are diving into details of key EMV tags, right? The important EMV tags, like I said in the first video, we just mentioned some few basics just to explain difference between application tags and transaction tags, right? However, we're going deep dive into some key EMV tags that play a crucial role in creating integrated circuit card during transaction, right? What I'm trying to say is they play a key role in creating ICC data during transactions, right? These tags not only facilitate secure and efficient, processing, but they also help maintain the integrity of the transaction. Okay, so let's explore each of these tags and understand the significance. So we're starting with AIP tag 82 application interchange profile. The reason why I am starting with this is because this is the tag that you will get earlier when you start an EMV transaction, right? This is the tag that you get that tells you what to do and what not to do, right? In an EMV transaction. So AIP tag indicates practically the card's capability, right? What are the cryptographic functions the card support? Does it support SDA? Does it support DDA? Does it support CDA, right? For card data authentication, right? What are those things that this card support, right? So this tag 82 typically helps out with the functions, the card holder verification methods, and a whole lot of things that is supported by the card, right? So this is a tag that tells you. So if you're maybe you're building an application or you're writing a kernel maybe for your soft balls, and then you want to write a kernel from scratch and all that, right? Or you're trying to emulate a card, right? It might not necessarily be a full-blown EMV card, right? This is the kind of tag that you respond with when a terminal, right, request for application profile, right? So that's tag 82. It helps to determine how transactions should be processed and verified, right? Tag 82 is quite large. We can probably do a video sometimes later to just pick on tag 82 itself to really explain what's the meaning of tag 82, and then how to read it out, the meanings of whatever you read from it, what are the decisions that you need to make and all that, right? However, like I said, this is just an introductory series, so yeah, so we'll leave it like this. Followed is tag 84. Tag 84 is the dedicated file names, is the name of the application on the card, right? It's being used to select the correct application for the transaction, typically, like we said before, right? And we have tag 95 tag that's terminal verification result. What does tag 95 does? Tag 95 is a result of various checks that are done by the card, right? Did I do offline data authentication? Did I do card holder verification? If I did that as a card, what was the result, right? Or as a terminal, rather. If I did that as a terminal, what was the result, and all that, right? That has to be passed with the EMV object, right? That has been sent as a TLV object that has been sent upstream, right? It helps in decision making for approving or declining transaction. We have now F2Cs, which is the application cryptogram, right? This is a very, very important tag, right? This tag is generated by the card itself during a transaction, right? The card uses some values that is being supplied by the terminal application, like the transaction amount, the currency code, the country code, to the transaction type, right? To transaction date, sometimes, to create a cryptographic value that the issuer would check when it gets to them, right? When the issuer checks this cryptographic value, they use it to know the integrity and then the authenticity of the transaction data. Like I said, application cryptogram has a lot of data in them. I've been able to divide them into two types of data, right? We have one, the terminal data, the other one, the ICC data, right? The terminal data is the amount authorized, the amount, the terminal country code, I can tell you, transaction currency code, terminal verification result, transaction date, transaction type, unpredictable number, and then in the ICC data we have the application integrity profile and the application transaction counter, right? These are what the card use in creating the cryptogram, right? This is what the card uses in creating the cryptogram data. That's application cryptogram, right? Then we have tag 9 F2Cs, is the cryptogram information data, right? It has to tell what kind of cryptogram was generated by the card, such as maybe is an authorization request cryptogram, right? Even acquirer or even an issuer, right? Okay, so let me just go straight to the table below, right? You can see an example of cryptogram information data and the possible meaning. We have 0000. It means no advice required, no specific cryptogram indicated, right? If I'm issuer or I'm an acquirer processor, right, I probably would reject this transaction. The reason why I will reject the transaction is I don't really know what's going on, right? It didn't tell me what kind of cryptogram was generated. It didn't tell me what advice you get. It didn't tell me if an advice is required or not, right? 0101 says that advice required, reason for advice is specified in second byte, which is the second 0 byte. It could be potential fraud, card without authentication issue, right? So if an advice is required in a transaction, what that typically is saying is that, guys, something has happened while this transaction is going on, right? However, it is now left to you to do mock checks to know what is going on in that particular transaction. I don't know if you get what I'm trying to say, right? So that is what the second value is. We have another type of 0101, 0001 rather. No advice is required, and then there's a cryptogram, right? Application cryptogram AAC is included, right? No advice required, terminal certificate included, right? That's if transaction was approved offline, right? So it generated TC, right? 0003 says that no advice required, application risk management cryptogram is included, right? So for people that does online transaction, that is transaction and not being approved offline, transaction is supposed to be approved online. Mostly ARQC is generated, and if ARQC is generated, most times the values that you should get is 0003. But I've seen cases where we have ARQC the value generated was 0001, right? I've seen cases where it's 0101. So this data is generated by the card to tell the condition of that particular transaction, right? Okay. That takes us to tag 9F10. Tag 9F10 is issuer application data, right? This contains proprietary data from card issuer, including authentication, risk management, and all that, right? Is used in verifying the card and transaction practically, right? Okay. The issuer is the one that uses this data just to verify that the card is valid and then the transaction is valid, right? We have 9F37, unpredictable number. Like you said, this is used to prevent relay attacks, just to know, to be sure that that transaction is unique, right? Application transaction counter, ATC increase with the transaction, right? It has to detect duplicate transactions and ensure the uniqueness of the transaction. Still, here is a card that gives us back, right? We have transaction dates, 9A indicate the date of the transaction, and it's being used for record keeping and verification. Transaction type is the same thing, defines the nature of the transaction. The most common type of transaction that you will see is purchase, cash withdrawal, and transfer, right? Which is 0001 and 50, right? There are some other type of transaction type 20, transaction type 30, and all that, right? So we have amount authorized as 902. We've spoken about right? It tells us the amount to be debited or the amount for that transaction. Amount order, they call it card order billing. It's using card order billing, right? It's specify additional amount related to that transfer social fee, right? That's what's called card order billing. Let's say what I'm doing is a transaction or a cash withdrawal, and I want the card holder to be the one to bear the cost of that particular transaction, that is the fee of the transaction, right? All I need to do is to pass in whatever fee that the card holder need to bear in this particular tag, right? And then use that fee the issuer uses the fee to debit the card holder, or they use this tag, rather they value this tag to debit the card holder that particular transaction fee, right? We have 9F2A currency code. Is used to tell what currency is that transaction is, right? Okay, this is a transaction that is to be done in dollar. This is a pound sterling transaction. This is an euro transaction. This is a naira transaction, right? Just tell what value, right? It helps issuer or processors to do the conversion at their end and all that, right? And it helps to even do that's for security. It's also for authenticity of transactions, right? So imagine a transaction is supposed to happen in naira, or imagine a system that does not support a dollar transaction. However, the terminal is sending upstream a 5F2A of a dollar currency code, right? The acquirer system typically will deny that, right? Okay. Terminal country code tells where that terminal is coming from, right? It still talks about the currency code of the transaction in a way, right? But it's typically where that terminal is, right? Yes, we are in 9F33. So 9F33 is an important tag, right? Just like 9F1A, right? Just like 9F1A that talks about terminal country code, right? 9F33 talks about the capability of the terminal itself. Don't forget AIP, which is the first tag, which is targeted to, tells the capability of the card 9F33 tells the capability of the terminal, right? They call it terminal capability. Offers context about the terminal, um, tells terminal what kind of card reader verification that the terminal supports, what kind of card data authentication that the terminal supports, and a whole lot of things, right? That the terminal support, right? It just tells the capability of that terminal, and then it tells both terminal and card to how to interact. So, for example, if my terminal supports only online pin, that is the application of my terminal support only online pin, right? And then a card comes and that card supports both online and offline pin. What happens is the terminal and the card makes a decision to say, you know what, I support online pin, and then you have online pin as part of your CVM list, right? So why don't we perform an online pin verification, right? If my terminal supports both offline and online pin, and then the priority in the CVM list, that is the first guy there, and the CVM list for the card is let's say offline pin, right? My terminal would practically move with offline, because one of the capability of the terminal is offline, right? So it moves with that, and then it goes on, right? So that's a typical explanation of tag 9F33. We have tag 9F34, card order verification method result. So this is an EMV tag that is one of the results of the transaction, right? Don't forget, right, where you see these tags is in what is called ICC data. That is, these data are packed together, right? They're TLV. It's a long, very long TLV data, right? It tells the card order verification process, right? What kind of verification happen? Is a pin? If it's pin, is it offline? Is it online? If it's not pin, is a signature? Is it no CVM, right? Is here a card holder device verification? There's a card holder device verification, that is where you send OTP to the device, and the device is the one, and then you always send a prompt to the device or the card holder's mobile device, kind of, right, for them to approve that transaction. And once they've approved the transaction is successful, right? Those are this particular type will tell you what the result of the card holder verification is, right? Then it takes us to 9F35. We have a terminal type. It tells us what kind of terminal is it attended, is unattended, right? This typically tells us what kind of environment, right? So attended terminal is for example, if you go to a store to make a purchase, and then there is a lady or a guy that is standing at a till to attend to you. Is a lady gets your card, insert your card to the POS, gives her the POS to insert your PIN. You give back the POS to the lady, and then when transaction is done, the lady gives the receipt. Somebody is there, operating that terminal, right? Those are attended kind of terminal. We have the unattended terminal. We have that is those ones that are there. Nobody's there. Nobody's the one controlling it. For example, a boss validator, right? A boss validator, all I just need to do is tap in, tap out, right? Nobody's really the one controlling. So those are examples of unattended terminal. So tag 9F35 tells you what kind of terminal is it that was used. 9F09 application version number. It tells you the version number of the application, right? For example, there are some acquirers that build the application on the terminals that checks the version number of that application, right? For example, the card has a pure kernel, which is what VEF card used in Nigeria, right? The card has a pure kernel, but the pure kernel on the card is a particular version, right? You need to be there there might be a little difference between an older version of PureKernel and the latest version of a PureKernel, right? It might be just one tweak, maybe one change that the card scheme has made to the applications that sits on those cards, right? You as an acquirer, or you as a payment engineer, need to take note. Oh, this version, this is a change, and you need to make that change based on it, right? Just to, ensure proper compatibility between the card and the terminal. We have 941, we have transaction sequence counter. This guy is maintained by the terminal, is incremented with each transaction. It's just a counter, right? And yes, that brings us to the end of key to the end of key EMV tags, right? These EMV tags are so important because they are the EMV tags that an ICC data, like that builds, or let me call them the building blocks of an ICC data in EMV transaction, right? And the ICC data in EMV transaction is the most important part of whatever message is being sent upstream, right? They ensure that every transaction is secure, is accurate, and properly authenticated, right? In the next episode, we would explore some more deep explanation on some tags, just to explain some tags more, and what their use is and all that, right? Thank you very much, and have a nice time.